Okay. Uh, so we are trying to do the OR table, OR truth table. 0 0 output is 0 0 1 1 1 0 1 0 1 1 0. So for that I wrote an equation, a truth table graph for which 0 0 leads to 0 0 1 1 1 0 1 1 1 is 1. So for that I wrote an equation related to this. Okay. um, okay, and here is what we will use this y is equal to mx plus c as an equation. So and the equation should be written in the form of ax plus bx plus c greater than 0. So minus 1 minus 1x minus 1y plus 5 is equal to 0. That means x plus y is greater than 0.5. That means anything for this to be truth table, okay, truth, okay, anything that is to be true. So here a x plus y should be greater than 0.5. So here a is equal to 1, b is equal to 1, and c is equal to 0.5. Okay, and so any point above this threshold will identify the R truth table. Now if at all I try to write this, okay, and this is the processing unit, okay, so wherein x1 I give x1 and w1 some weightage and process go through this processing unit, where y with this y, this processing unit actually tells me also has the threshold of this processing unit does this part of the equation, and it has to pass through another threshold. Okay, so here another threshold is there, sorry, this threshold is the greater than 0.5. Okay, not this one. Okay, not this one. So this will give me the final edge of the desired output, that is the z. No, not z, sorry, y. The z is the one which is in the truth table. Okay, this is z, sorry. Okay, z. Now if at all I need to, if I at all I want to, so I will go with some weights. So what is this whole thing related to is, the reason is because we need to understand this processing unit. So truth table is going to be fine, but these w's are what we are worried about. What is that w that I should have such that this particular neuron gives me my desired output, my actual output. The actual output is this. Okay, z is the actual output. Not the desired output. Y is your desired actual output. Y is your actual output. Sorry, y is your actual, and z is your desired. Desired output. Okay. Now, if at all I need to, if at all, what should be my weights to be considered? What is my weight of this x and y, x, the input x that needs to be there, such that I have to adjust. You understand why I'm talking about this adjustment? I have to tweak a little bit of these weights such that I get my desired output. That is what the neuron does. All in the whole of the things that you need to understand in neuron and the neural network is, what is it that output, what is that I should adjust these weights, what should be my weights in such a way whatever the input that comes gives me my desired output. Now for that I have to do what I will do, what I do get is this y output and this threshold, and I'll get some output of some output here, but that might not be the actual desired output. That this actual output might not be the actual desired output. So I have to tweak the weights such that my next in my next iteration or my next output should be get adjusted in such a way that my output is coming closer to my desired output. So that's what we talk about is this contours, is this, like say w1 and w2. Okay, now I have to reach this particular point where all my outputs, all my desired output, or my actual outputs is equal to my desired output. That means I have my weight somewhere sitting over here in this particular graph. Okay, so let's say my graph is my first set, my first initial w's are somewhere over here. Okay, w1 and w2 are over here. That means 0.2 and 0.3, something like that. But how do I go to a point where this one is the ideal weight, where each of my actual output is very close to my desired output? That means I have to move somewhere over here, I have to move this side, or I have to move this side, or I have to move this side. My desired, weights should be in such a way that it should reach the contour, this contours or circles, such that it actually reaches this point rather than in any other directions. Now, how do I wiggle that? How do I actually wiggle this information such a way that actually this processing unit which is there sends me proper input, proper change in the outputs of this, such that my next iteration gives me the actual desired output, desired weight, such that my actual output is very coming close to my desired output. So this is what this actual whole thing related to one neuron, only one neuron. Remember, there are several neurons in a particular neural network. This one neuron, how does it actually works, is what I'm trying to make you understand with an R truth table. Now let's come to this. This is what it actually does. So how is my desired output comes into existence is, now let's look at it. You know that I drew this particular thing, right? Then, well, so this output is going to be something like this, which is outside of this, where y is equal to x, y is equal to mx plus c, and that we came to x plus y is greater than 0.5. That means anything above this threshold of 0.5 should give me the actual ones. Why? Because the truth table of one R table gives me these 2 points which are to be considered. Now, how do I look at it? Now, for example, sorry. Now, how do I look at it is this one. For example, my desired output is 0. If at all I start with, let's say, is somewhere is 0.1. Okay, I'll start with some weights. Okay, 0.1 and 0.3, and the what is the y equation? Y is equal to x. Okay, one second. What is the y equation? Y is equal to w1 x1 plus w2 x2, right? If at all you use this equation, the y will come to be it is going to be 0. But my sigmoid function is, what does it say? Anything that is less than this line 0.5 is less than 0 is going to be, anyway it is going to be 0.5, right? It's going to be 0.5. That means my first iteration will give me, okay, either it is going to be y is going to be 0. My desired output is 0. Here is 0 and here it is 0. The weights would be same thing, 0.1 and 0.3. Okay, now if at all I go, I make these, I apply these w1 and w2 to be something like that. Okay, how does these are the new weights, that I would like to use. The ones which I got it through this is through this weight. Okay, how would I tell it as not this what is the equation of this new w1 is this one. Okay, I'll just write it down here. The new w is equal to w I, okay, here in this case w1 plus rate of learning rate into delta, okay, into xi x1. Now here I have considered rate is equal to, learning rate is equal to very less, r is equal to, sorry, r is equal to 0.2. Okay, so if at all I multiply 0.2 into delta, what is the delta here in this first equation? What is delta? That also let me write it down here. Delta is equal to z minus y, right? That means 0 minus 0. Okay, 0 minus 0. So that 0 minus 0 into everything would be the same. That means W1 will be 0.1 and 0.3. Now what I will do is I will take this 0.1 and 0.3 as my next, in the next iteration, that will be my new number, 0.3 and 0.3. Now if I multiply this, okay, the output should be 1, but it will be 0. Why? I apply this, y is equal to, it will be 0.3 at the, not 0, but it will, the next iteration will be 0.3, but it is anyway less than 0.5, so it is going to be 0 again. The output would be the actual the desired, or the z, the delta, this I should say delta. Okay, the delta will be 1. Okay, why this will be 0? 1 minus 0 is 1, so delta will be 1. Now if I apply this formula, this will become, one second, I have the answer here somewhere. This will become 0.1 and 0.5, 0.1 and 0.5. Now this 0.5 will be used over here, 0.1 and 0.5. Now if at all this same thing gets applied over and over again, you will be able to see that the weights are getting changed for every iteration. In every iteration, in the sense, this whole truth table of 4 inputs is one iteration, and if I consider that as part of the iteration 4 times, if I do the epochs of 4 times, then the final answer would be the new weights, when what we started with 0.1 and 0.3 would become 0.7 and 0.7. For that, I will show you one. I wrote a code for that, actually how it works. So let me run that. So I'll show you the code part right now. So here is something. Okay. So I wrote this code wherein I have taken x1, x1 as 0, 0, 1, 1, x2 as 0, 1, 1, 0. That means this x1 is the most significant bit, x2 is the least significant. Z is the desired outputs. I have done a zip of that, but this is not necessarily listed. So anyway, that W weights, I started with 0.1 and 0.3 as the initial weights, and the learning rate is 0.2. So let's not understand this for loop first. Let's understand this part. I'm just printing this first line is printing. So y is equal to W1 into x1 plus W2 into x2. This is the actual output. If y is less than or equal to 0.5, y is equal to 0, else y is equal to 1. So this I multiply, but I am checking whether if it is 0 or 1. I just need 2 answers here, 0 or 1, that's all. So delta is equal to Zi, which is the Zi is this one, minus the output. I printed that, I am rounding it, but printing it. But the next time I'm actually, by this time what happens is, the new W's are actually being appended here. What am I doing? I'm taking my first, this one, whichever is the first value over here, whichever is the first second value over here, I'm doing one by one. I'm taking the delta into learning rate into the xi of 1. That means I'm rounding it here, don't worry. I'm taking xi of I. So they, based on that, what I'm doing the same thing what I told you over here. That is, I am adding the, I'm actually trying to come closer to the contour, to the middle of one, which actually might give, doesn't matter what value I have, x1 and y2, it's going to give me proper answer to it. Okay, the reason is because here, if you look at it, my desired answer was supposed to be 0, 1, but when I took the weights over here, the first one gave me 0, fine, but for the second one it is going to be giving me 0. Here also it is going to be 0. Here it is 1. That means these two outputs, which are supposed to give me 1 and 1, were giving 0 and 0. So for that reason, I'm actually adjusting. I'm tweaking the answer, the weights, not the answer. I'm tweaking the weights in such a way that it actually it actually gives me to the desired output when the weights are correct. Doesn't matter what happens to x1 and x2, my desired out, my actual output will be equivalent to the desired output. How? By tweaking this w1s and w2. For that reason, I did this, and if I run this, I get this answer. See, this is the first truth table, 0 and 0, the actual output is 0, 0 and 1, 1, 1 and 0, 1, 1 and 1, 1. But if you look at this desired output, Z, this one, this is my actual output 0, actual output 0, second one 0, the third one is 1. By the time these are the weights, the modified weights, W0 and W1 and W2. That one I'm actually putting it back over here. This one I'm putting it up actually over here. By the time it is the fourth iteration, doesn't matter what, it actually has the actual desired output has actually come over here. See this? It is 0, 1, 1, 1. But previous to that one, what happened? If I take these three, these four, it is still not good. 0, 1, 0, 1, I'm still getting it. By the time in the next epoch, this is first to 4 is first epoch, next second iteration, third iteration, this is the fourth iteration. So this is how you actually solve this particular thing. This is just for the OR table. Now how do you do it for the AND table? Now if you look at the AND table, okay, the AND table would look something like this. The AND table would look something like this. For example, I draw this. What is the truth table of AND? 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. Right? That means if this is 1, this is 1, if this is 0, doesn't matter what you get, the only thing that is good to have this is this one. Rest of them is all, okay, sorry. Okay, that means anything less than certain point is always not point. If this point is, if a line, if I try to draw a line from here to here, it would go from 2 or 3, right? If at all you draw this, if this is 1, this is 2, this might go from here to here, right? It might go from here to here, 2 through, but this is too far. The best one would be a line that would go from 1.5 to 1.5. That means your slope is 1.5, somewhere at y point it is, c is cutting at 1.5, and here it is 1.5. So that means the line, anything above this, right, any point that is above this will give me a truth table for the AND. Anything less than is 0. That means ax plus by plus c is equal to 0. But for the equation, it would be what would be the equation? I think it is 1x plus 1y should be greater than 1.5. Only then this is the truth, this is the equation for the and truth, for the truth table of AND. Okay, 1x plus 1y plus 1.5. Now if you look at it, if I put this particular code in here for the same thing, okay, in here, if at all I put the code, I did not do it, but it would be dangerous. If I put this here, okay, let me do one thing. I did not have to do that. It is the same. The output is the supposed to be. right? So if I look at it, what is my greater than this? This I need to put it. Anything less than 1.5, okay. Anything less than 1.50, anything greater than 1.5 would be 2, it would be 1. So if I change this part and I run it, my epoch would be different, right? Now this is the actual one. The final part would be, even in the second one it gave a good one, third one is also good one, but finally by the fourth epoch it is good to go. So anything which is zero 0.3, 0.5, even this should not have been. So this one will be a good one. Will be a good match. Would be the oh, okay, the output itself gone bad. So anything, I think the third epoch is a good epoch. Finally, why? Because this one is actually giving me zeros, all zeros. So I think by the first epoch, the second epoch, this one seems to be a good one actually. Okay, this one seems to be a good one. This is 0.7 and 0.9. At that point, it gives me a perfect match of the actual thing. That's the reason why this kind of things, what happens, we need to be very careful at what point it is actually giving and what it is not. At that point, we have to stop the iteration. That means at a certain point, if it goes and it might actually reverse back and come back and hit you, that means it goes, it acts like a boomerang. Now, okay, so we have to be careful at what point it is a desired output and we need to stop. Okay, so this is what I wanted to talk about. Okay, so today's neuron, I hope you have understood how to go ahead with the neuron, what is a neuron, and how actually it's supposed to be worked with. And if at all you look at it, what kind of a neuron, I'm just giving a kind of a exercise. If it is an XR, is one neuron good enough, or do you need two equations? And if so, how would you write such a neuron? For example, if it is XR, what is the truth table? 0 0 0 0 1 1 1 0 1 1 1 0, right? So this is X1, X2, and Y and Z. Okay. Now, if at all you look at it, okay, this is 0 1 1, right? The answer is, when it is 0 and 1, so this is your answer. If it is 1 and 0, this is your answer. For both of them, 1 and 1, it is here only, right? It is not 1 1 and it is at this side. That means somewhere in between your answer, somewhere in between these two is your answer, right? Somewhere in between. That means there is a one equation which goes with at 0.5 and another equation which goes at 1.5, right? This is 1.5, this is 0.5. So you need to have two equations which are, let's say this is A and this is B. So A is equal to your X plus Y less than 1.5, right? Why less than 1.5? Because you need something in here and you need X plus Y greater than 0.5. So how would your neuron would work? There would be two neurons and one summation. One neuron would go something like this, which is X1, this is X2, right? That which will go through one of the weights and which will go through one of the weights. And this will go through one of the weights and this will go through one of the weights. What are those weights? How do you adjust it? And